Good morning, everyone. Today we're starting 11.3. We are going to actually solve radical equations this time instead of just simplifying. So how we solve radical equations is by squaring both sides of an equation. So in words, what that looks like, it says if two expressions are equal, then their squares are equal. In algebraic terms, if a equals b, that means that a squared equals b squared. Or an example, if the square root of x equals 3, then the square root of x squared equals 3 squared. So how we're going to do this is basically we are just going to solve this equation like we solve any other equation. First thing we got to do, we're going to move, we're trying to get x by itself, so we're going to move this 8 over to the other side, because remember we're doing PEMDAS, or the order of operations, but we're actually doing it backwards. So we start with addition or subtraction, getting rid of that. So we're going to start by adding 8 to both sides. If I get rid of those, I get 2. The square root of x equals 0 plus 8, which is 8. Now what's happening with the 2 and the x is they are being multiplied together. So what I'm going to do is I'm going to divide to get the square root of x by itself. So now I get the square root of x equals 8 divided by 2, which is 4. Now, how we get rid of the square root is what we're going to do is square both sides of our equation. The square root and the squares, they cancel, so we're just left with x. 4 squared is 16, so we're saying that x equals 16. Now we can check that to see if we're right just by plugging that 16 back in. So it'll be 2 times the square root of 16 minus 8 equals 0. Well, we know the square root of 16 is 4, so it'll be 2 times 4 minus 8 equals 0. 2 times 4 is 8. 8 minus 8 does equal 0. So we know we did this correctly. X equals 16. Same thing here. What we're going to do is add the 3 to get that to the other side. So we'll get 12 times the square root of x equals 0 plus 3. Well, that's 3. Now what I'm going to do is divide by 12 because 12 and x are being multiplied. Okay, so if I divide by 12, then those cancel. I get the square root of x equals 3 divided by 12, which is actually going to give me 1/4. So now we need to get rid of that square root. How we do that is we square both sides. So if I square this side, I'm just going to be left with x. Now if I square this, I'm going to square the top, so it's still going to be 1. And then I'm going to square the bottom, so 4 squared is 16. So my x is 1/16. Now we need to check that to see if we are right. So what we're going to have then is 12 times the square root of 1 over 16 minus 3 equals 0. Well, let's see if this works. So the square root of 16, that's like saying the square root of 1 over the square root of 16. The square root of 1 is 1, square root of 16 is 4. So 12 times 1/4 minus 3 equals 0. 12 times 1/4, 1/4 of 12 is 3, minus 3, 3 minus 3 is 0, so 0 equals 0. Okay, next one. We are going to here subtract 5 from both sides. Those cancel. What I get then is the square root of 5x equals a negative 5. Now this is where this problem should bring concern. Because right now it looks like it says the square root of something is going to equal a negative number. Now the square root of something is never going to equal a negative number, because the square root of, let's say, 16 is always going to be 4. Or it's always going to be a positive number because the two numbers have to multiply together. So right away we can say that this is no solution. If you wanted to check that, we totally could. What we're going to do then is square both sides. So we would get 5x equals negative 5 times negative 5, which is 25. If I divide that by 5, I get x equals 5. Now I would have to put that back into my equation to see if it works. So I'll get the square root of 5 times 5 plus 5 equals 0. So what I get is the square root of 25 plus 5 equals 0. Square root of 25 is 5. 5 plus 5 equals 10. 10 does not equal 0. So this problem does still have no solution. Whenever you see a negative number in as your answer, you know that this is going to equal nothing. You're not going to have a solution. Alright, now this looks a little bit bigger. We're still going to solve it the same way. So we're going to subtract 12 from both sides. So we get 4 times the square root of x minus 7 equals 28 minus 12, which is going to give us 16. Now what I see is 4 is being multiplied, so what I'm going to do is divide everything by 4. 4 divided by 4 is 1, so I don't need that anymore. I get the square root of x minus 7. 16 divided by 4 is going to be 4. Now I'm going to square both sides to get rid of my square root. So when I do that, those cancel. I get x minus 7 equals 4 times 4, which is 16. Add 7, add 7. X is going to now equal 23. Now again, I could check that, and I could put 4 times 23 plus 7 plus 12 equals 28. So it would be 4 times the square root of 30 plus 12 equals 28. So now if I do the square root of 30, now this is something I would probably want to put in my calculator. So the square root of 30 gives me about 5.5. I'm going to multiply that by 4. I'm going to add 12. So 4 times 5.5, about, now it's not exact, that gives me about 22. Plus 12 equals a 28. 22 plus 12, that's going to give me 34. This one doesn't work. So we have 34 equals 28, which we said that does not work. So this one also has a no solution. Alright, so now we have to solve an equation with radicals on both sides. So what we're just going to do is we're going to try to get rid of our radicals. Now how we get rid of radicals? Well, we have to multiply them both by themselves. We have to square them. Now a square root and a square, they're going to cancel out. I'm just going to left with 3x minus 17. Again, they're going to cancel out. I'm going to be left with x plus 21. So now this is pretty easy. I know how to solve this. What I'm going to do is try to get all my x's to one side. So here I'm going to subtract x from both sides. 3x minus 1x is going to give me 2x minus 17 equals 21. I'm going to add 17 to both sides now. So we get 2x equals 21 plus 17, which is 38. Divide by 2, and x equals 14. Now what we got to do is check that though. Let's see if that works. So it would be 3 times 14 minus 17 equals the square root of 14 plus 21. Remember, I got to square root both sides. So I'm just going to put these into my calculator. The square root of 3 times 14 minus 17, that's going to give me 5. Then I'm going to do the square root of 14 plus 21. That's going to give me 5.9. So this one doesn't work either. So that's why we have to always check these. They might work and they might not. Here for this one, I have 2 radicals. Now what I want to do is I want to get a radical on both sides. So what I'm going to do is add the square root of x to both sides. So I'm going to get as the square root of 4x minus 3 equals the square root of x. Now I want to get rid of those radicals, so I'm going to square both of them. Then I'll get 4x minus 3 equals now just x. I want to get x's all by themselves, so what I'm going to do is I'm going to move over the 4x. So I get negative 3 equals a negative 3x. Divide by negative 3. And we're going to get x equals 1. Now if I check that, it would be 4 times 1 minus 3 minus the square root of 1. And the square root, so 4 times 1 is 4 minus 3, that's the square root of 1, minus the square root of 1. Well, that's going to give me 0, so this is true. X does equal 1. Alright, 6 we're going to skip. We're going to go on to 7. Here we need to get rid of everything first, addition or subtraction. So we're going to add 12 to both sides. So we get the square root of 5x plus 4 equals negative 6 plus 12. That's going to give me 6. Then we're going to square both sides. So we get 5x plus 4 equals 6 squared. Well, that's 36. Now I'm going to subtract 4. And we get 5x equals 36 divided, or minus 4, which is 32. Divided by 5. We get x equals 32 divided by 5 gives me 6.4. Now I have a decimal, 6.4, so that's probably going to tell me, well, it might not be right. So I'm going to put that back into the equation. So I'll have the square root of 5 times 6.4 plus 4 minus 12 equals a negative 6. So, well, the square root of 5 times 6.4, that's 32, plus 4. So 32 plus 4, that's the square root of 36. Square root of 36 is 6 minus 12. 6 minus 12 is negative 6, which equals a negative 6. So this does work. 6.4 is our solution. Alright, last problem. It says solve an equation with an extraneous solution. Now we haven't seen this word before, but this word has the word extra in it. So that's going to mean that this problem is going to have an extra solution. So what I see is a radical on one side and nothing on the other. So I want to get rid of that radical, so I'm going to square both sides. That's going to give me 6 minus x equals x times x, which is x squared. Now we've seen problems like this before. In chapter 9 we have seen x squared before. So what we're going to try to do now is solve this. So I want to move everything over to the x squared side. So I'm going to add x to both sides. So we get 6 equals x squared plus x. Then I'm going to subtract 6 to get everything over to this side. And now we get 0 equals x squared plus x minus 6. Now, if you think back to chapter 9, we have seen this before. This we're going to factor. So the first thing is x squared times negative 6, which gives me negative 6x squared. Then the bottom is plus x, so this is going to be a 1x. Now the factors I know that are that multiply to 6 are 2 and 3, but one of them has to be negative. So what I'm going to do then is I'm going to make a negative 2, so that both 3x and negative 2x add up to 1. Then I got to draw my box so I can factor this. What goes in this is this top left box is a, so I'm going to put 1x squared. In the bottom right is c, so I'll put negative 6. Then I have a 3x and a negative 2x. Well, x times x gives me 1x squared. X times 3 gives me 3x. And x times negative 2 gives me negative 2x. Then negative 2 times 3 gives me negative 6. So what we get then is x plus 3 and x minus 2 equals 0. So now we got to solve this. X plus 3 equals 0 and x minus 2 equals 0. So we got to subtract 3 from both sides for the first one. So we get x equals a negative 3. Here we have to add 2 to both sides. So we get x equals 2. Now if you remember back to the second slide, or one of the first slides, we said that we cannot have an answer if we have a radical of a negative number. So the negative 3 is our extra solution. Our actual solution is just x equals 2. This one we have an extra solution.